Okay, in a previous video, we looked at how given the position versus time graph to get the velocity versus time graph. Now we want to go the other way. So we know the velocity versus time graph, right? So this is velocity here and this is time. And we would like to obtain from that information the position versus time graph. So to deduce the position versus time graph, we need to look at the signs of the slope. For instance, here we have, this is a velocity versus time graph. In this axis we have velocity, and here we have time. Velocity here is in meters per second, and time is in seconds. So then from 0 to 15 seconds, the person has, or the object has, a velocity of 1 meter per second, and it's positive, right? This is positive. And then from 15 seconds to 20 seconds, it has a velocity of minus, this is a negative velocity, minus 3 meters per second. So what would then be the position versus time graph? Assuming that the person starts at 0, then it moves with a positive velocity up to 15 seconds. That means it has the position versus time graph should have a positive slope, right? So the inclination here should be positive. Then from 15 seconds to 20 seconds, this is a negative slope. Then you get a negative slope here. Also, this is 1, this is 3, so the slope, this slope is going to, this one here is going to be steeper than this. So you can see it has some inclination here, but this is steeper, right? So, and this is your position versus time graph. If it starts at 0, then it's going to move to 15 seconds at some velocity, and then it's going to move backwards with this much velocity here, moving faster here. The speed here is greater than here. So now we would need to find the point here where it reaches this peak here. And to do that, what we would do is take the velocity and multiply it by time. So here, for instance, the velocity is 1 meter per second over 15 seconds. That gives me 15 meters. So the point here has to be 15 meters. And then here, then you get 3 seconds and over 5 seconds. So 3 meters per second over 5 seconds. That gives me 15 meters again. So it goes back to the initial point. So it goes at a speed from 0 to 15 meters at a speed of 1 meter per second for 15 seconds, and then comes back at minus 3 meters per second for 5 seconds. So that is how you get the position versus time graph from the velocity versus time graph. So let's look at 2 questions just to understand this. So here we have a motion diagram, and then you have some velocity here and then some velocity in this segment, and we would like to find the position versus time graph from this motion diagram. Take a minute, try to answer this, and then come back to the video. All right. If you answered this correctly, then you should have gotten E. And so you can see here that the velocity, the speed, the velocity is positive in both cases. The speed has a value here and then has a greater value here. So you would get some slope here and then a steeper slope in the second segment. Now your 0 is right here. That means that you cross the origin at this point. So that is why you chose this and not this one here, because of the origin being chosen at that point. Let's look at another question here. So now we have a velocity versus time graph of a hockey puck. So what would be the right position versus time graph? Take a minute to answer this question. All right, if you answer this right, then this is the right answer here. So the puck starts here and then it moves with a constant speed. So the position is going to increase. It is positive, so it goes around this, and then at this point the velocity is 0, so it's going to stay there, right? It's not moving here, so that means the position is not changing, so you would have a horizontal line here.